Hello, I'm Hojae Son from XXL Lab. Today I'll be presenting Prismatic world model, which focuses on learning compositional dynamics in hybrid systems. Let me start with the problem setup. In robotic environments, especially with humanoids and quadrupeds, we often encounter hybrid systems where different types of dynamics, such as contact and flight, are mixed together. In these systems, we observe frequent mode switching, including contact states, non-contact states, and external perturbations. The problem is that monolithic world models struggle to handle this effectively. Because a monolithic model uses a single network to learn all dynamics, it often suffers from oversmoothing. As a result, the model learns something that is neither true contact dynamics nor true flight dynamics, but rather a kind of averaged, unrealistic dynamics. To address this issue, the paper proposes a mixture of orthogonalized experts. The core idea is simple. We use multiple experts. Each expert learns a different type of dynamics. A gating network selects the appropriate expert depending on the situation. For example, one expert models contact dynamics, another model flight dynamics, and another hands stabilization. So instead of a single model, we decompose the problem into specialized components. Now, let's move on to the method. The overall framework is based on the net latent world model. The encoder maps observations into a latent space. The dynamics model predicts the next latent state. Importantly, the dynamics is not modeled by a single function, but by multiple base dynamics, or experts. There are three key components. Gating network. It selects which expert to use based on the current state. Multiple experts. Each expert learns the relatively simple dynamics, and complex behavior emerges from their combination. Orthogonalization layer. This enforces diversity among experts, so that they specialize in different roles. Let's look at how this works in practice. Under normal conditions, the gating network selects experts in a rhythmic pattern, for example, during a work cycle. However, when an external disturbance occurs, the system quickly switches to a stabilization expert. In other words, the model can adaptively switch dynamics models depending on the situation. Now, for the experimental results, the graph shows reward versus environment steps. We can see that Prism world model outperforms prior methods, especially on high-dimensional humanoid tasks. The improvement is particularly significant in contact-heavy tasks and environments with complex dynamics. To conclude, in hybrid dynamic environments, monolithic models suffer from oversmoothing. To solve this, the paper proposes a mixture of orthogonalized experts. With gating, multiple experts, and orthogonalization, the model can learn mode-specific dynamics effectively.